Hi there, hope you have a fantastic day today. This lesson I will teach you how to write vectors in component form. Of course, there's the PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Let's say we have a vector OI is 2, 3. This is column metric form. So we can also write this in component form. So component form means it involves I and J components. So I is represent the horizontal component, and whereas J is represents the vertical component. So this means that this is also equal to 2I plus 3J. There you go. Second example. Let's say we want to express AB in component form. So AB at the moment is displacement vector. So express that in component form. So what we need to do is we need to draw a position vector that equal to AB. So you can say AB is the head of this vector here is I, start from I, and it go down 2 units and across 4 units. So therefore, let me just draw a position vector that's equal to AB first. So there you go. So this is the component vector. So therefore, the component vector of AB, so I can write AB is equal to 4I and then minus 2J. Otherwise, you can also work out AB algebraically. So we know that AB is equal to AO plus OB. So therefore, we know that AO is negative OA. So we add OB. So that is equal to OB minus OA. And we know OB is 0, 2. And minus OA is negative 4, 4. So if we minus the two vectors together, so the x coordinates, which is 0 minus negative 4, so give me 4. And then we have 2 minus 4. So will give me negative 2. So this can express as in a component form. So that is 4I minus 2J. So J is the vertical component and then I is the horizontal component. So you can see we have 4I minus 2J, 4I minus 2J. Let's say we have another vector. Let's say the magnitude, vector I, had a magnitude of, let's say 6 units. And the directions is 150 degrees. So to express the vector I in component form, so first of all, let me just draw the diagram out first. So vector I has a directions of 150 degrees. And the magnitude is 6 units. And the directions is measured from the positive x-axis and go anti-clockwise. So 150 degrees. So therefore, this must be 30 degrees. That is the reference angle. So now we just need to find I and J components. So this is a right angle triangle here. So let's say x, we want to find x. So because in this quadrant, we know x is negative, right? So we just work out the magnitude first. So therefore, the x, we have adjacent and hypotenuse. So it's car. So we know that. So cos of 30 degrees is equal to adjacent, that is x, over hypotenuse, which is 6. So which is times 6 both sides. So that will give me x is equal to 6 cos of 30. But then cos of 30 is root 3 over 2. So that means 6 times square root of 3 over 2. And then I just cancel this. Give me 3. So that is 3 square root of 3. But then because in the second quadrant, so x is negative. So negative 3 root 3. Now let's work out the j component. So j component is a vertical component. So let's say this is y here. So we know that opposite hypotenuse, so psi. So which is right here. So psi of 30 degrees is equal to opposite y over hypotenuse. So which is 6. So we times 6 both sides. So that will give me y is equal to 6 psi of 30 degrees. So therefore, psi of 30 is a half. So therefore, a half of 6 is 3. And of course, because in the second quadrant, the vertical component is positive. So therefore, the vector I is equal to negative 3 root 3i plus 3j. There you go. Please pause the video and try this one yourself. Hi, I'm back. How do you go? So let me go through them with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So to express negative 3, 5, that is the column metric form. To express into component form. So that will give me 3 negative 3i. We add 5j. That's all. Now part B. So to express PQ in component form. And we know that PQ is a displacement vector. So therefore, we need to draw a component vector that is equal to PQ. Okay? And we know that from P to Q, it goes down 1, 2, 3, 4 across 2. So we go down 4 across 2. That's it. So we go 1, 2, 3, 4, and then across 2. This is the position vector that is equal to PQ. So this is 2, negative 4. So that is equal to 2i minus 4j. There you go. Last one. So V has a magnitude of 12 units and with a direction of 300 degrees. So let me just draw the vector out first. So 300 degrees. So it's from here to here, okay, on the fourth quadrant. So therefore, the reference angle must be 60 degrees. Because 360 minus 300. So that is 60 degrees left. So therefore, the acute angle or reference angle, if you like, is 60 degrees. And we have the magnitude of 12 units. So therefore, we need to find the vertical and horizontal component. So the horizontal component is x. So we find x. So go adjacent hypotenuse. So which is cos. Cos of 60 degrees is adjacent over hypotenuse, which is 12. So x must be equal to 12 cos of 60. But we know that cos 60 is a half. So a half of 12 is 6. So that is 6. And in this quadrant, which is fourth quadrant, x is positive, okay? So for vertical component, this is y. So opposite hypotenuse. So that is psi. So we go psi of 60 degrees equal opposite over hypotenuse, which is 12. So we times 12 both sides. So that is y is equal to 12 psi of 60. But then sine 60 is root 3 over 2. So that becomes 12 times root 3 over 2. So 12 divided by 2 is 6. So 6 root 3. So therefore, for horizontal components, we have 6. And vertical component is 6 root 3. But then because on the fourth quadrant, So the y value must be negative. So you got therefore y is equal to negative 6 square root of 3. So therefore we can write vector v is equal to 6i minus 6 root 3j. There you go. I hope you got all of them correct. Thank you so much for watching. Bye.